Okay, so section 2.5, linear and nonlinear relationships. So let's see what that means. Basically, our goal for today is that by the end of this section, by the time you finish this note, you know how to draw a line of best fit, and you know when it's appropriate to use a line of best fit. And I suppose maybe most importantly, you know what a line of best fit is, of course. So, first of all, the term linear relationship, what does that mean? It means that if you took some data and you graphed it, you would get a straight line, or approximately a straight line, and that's the idea of a line of best fit. But it just means, you know how, remember, you have an x-axis, which is horizontal, a y-axis, which is vertical, and you have a bunch of data, and if you graph it, you get a straight line. Okay? That's linear. Okay? A linear could also mean, by the way, same idea, but a linear could mean in that direction. It doesn't have to be straight up. And I have to give you an apology ahead of time that I'm generally fairly lazy with using a ruler. So, we're assuming that my messy line is straight. Okay, so next, what is a line of best fit then? It's a straight line that if you had a whole bunch of data and you plotted it, a line of best fit would basically approximate what that data looks like. So here's just another quick example, and you'll see more as we go through the note. But imagine you collect a bunch of data, and it kind of looks like this. This is your data point, and we wanted to draw a line of best fit. So you may have in the past sort of connected all the dots, and we don't connect the dots anymore. That will never happen. What we do is we draw a line of best fit. So I would, in this case, draw a line that might sort of approximate all the data. Okay, that would be what I'd call a line of best fit. Okay, so a line of best fit doesn't have to touch any of the data, quite frankly, but it does sort of show the general trend of all the data. Curve of best fit is the same idea, but it's when the data quite clearly doesn't follow a straight line, what we call a linear relation. It has some other relationship, and it's obvious that it's in a curve, and it doesn't follow a linear. Okay, and we'll do a couple curves of best fit, but we don't do a lot of that in grade 9. We don't worry about curves very much. Grade 9 is all about straight lines, and we're going to see a lot of that in the rest of the course. Okay, so just an example, if you had the data, right, could you draw a line of best fit? So basic idea is you try to set it out so that you should have the same number of points above the line as below the line. It doesn't have to be, you don't have to count them, but it should look like that. So I actually never did count this when I did it. 1, 2, 3, 4 below and 1, 2, 3 above, and then it kind of touches several of the data points. So that's a fairly close line of best fit. Okay, because it's approximations, your line and my line might be slightly different, and that's okay, as long as the line seems to follow the trend of the data. Okay, so when to use a line and when to use a curve. So this example should show you that, if I tried to draw a straight line through this data, it wouldn't be anywhere close, right? I could draw a line right here and sort of say, okay, half above and half, something like that. It just doesn't work. In this case, a line of best fit is not an appropriate choice in this. This is where you would use a curve. Okay? And if I was going to draw the curve, I could probably follow this data fairly nicely if I was better at using my pen. But you could pretty nicely follow this data all the way through with a curve. Okay? And a curve you wouldn't use a ruler for. So my choice to be lazy and not use a ruler works just fine on a curve of best fit. Okay? However, this data will be a line of best fit. I can tell just by looking at it. It has a wave to it, but if I tried to draw a straight line, I could find something that works fairly good for it. So I could maybe go from here, something like that. And I can everything's kind of close to the line, so it works. This one I know it just doesn't work because all the points get too far away. It's impossible to have it sort of equal. This one, on the other hand, does work for a linear, what I call a linear relationship. Okay, so I guess that's it for today's note. Quick and easy.